Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this video we will be starting our third important algorithm in our clustering module, in our unsupervised machine learning module, which is about Dbscan. So until so far, if you remember, we have completely in detail covered up about k-means, followed by hierarchical clustering. We have seen the mathematical intuition plus the implementation for both of these algorithms. Now, this is again one of the most important clustering technique that we are discussing in today's video, which is about Dbscan. And let me tell you, in most of my practical use cases, where that k-means algorithm or hierarchical clustering algorithm fails, Dbscan would be the rescue for me, and it really saved me, especially in those instances where the need of outlier detection came into picture. So yes, please try to understand this video also in a very conscious manner, so that you will be able to understand each and everything in a very detail. So without wasting any time, let's get started with this journey of Dbscan as well. So now, as you can see on my screen, the full form of Dbscan is density based spatial clustering of applications with noise. Let's try to understand that, how internally, with the mathematical intuition wise, it will be able to help us to give the clusters based on the similar patterns, right? So here, I think on the left side, you can see the proper visualization for the same, where the important thing to understand in this Dbscan algorithm is there are 3 points which we have to understand. One term which you can see on the picture itself is the core point, right? What is the meaning of core point? Let's try to understand that aspect. Second point you will observe is border point. Let's try to understand that as well. And at the very end, I'll try to discuss about something called as noise, which we also called as outliers in case of Dbscan algorithm. Okay. That's why, if you remember in the intro part of the video, I told you that this algorithm is very widely used in order to detect the outliers available in the data. How is that so? Let me try to, help you out in order to explain that aspect as well. So here, if you will be able to see the red points in the diagram indicates the core points. What is the meaning of core points? First of all, let's try to focus on that aspect. Okay. Now here you can see very clearly that there are two variables which will be available in your Dbscan algorithm, density based spatial clustering algorithm. What are those two parameters? One is called as EPS, epsilon. Another one is called as minimum points, which you can see on my picture as well, right? Epsilon indicates the radius value with respect to the circle that they are trying to create. For example, let's say I will be having this data point available with me. So what I will do is I'm trying to create a cluster. I'm trying to create a cluster or a circle with respect to some radius. So this point and this cluster, the radius of that is something which we are saying it as a epsilon. Okay. Second parameter is minimum points. In this particular circle, in this particular cluster, how many number of minimum points we are allowing? That is something which is indicated by min points parameter. So there are two important parameters, and these two parameters are something which we call as hyperparameters. What is the meaning of hyperparameters? Depending upon which kind of data you are dealing with, these values keeps on changing. In the upcoming module, we will talk about that how can we fine tune these hyperparameters that we are dealing in different algorithms. But as of now, in the today's session, I'll take fixed number of EPS and min points, and we'll try to do the implementation. But you have to understand that we have to take care of these two values in a very great detail. Okay. Now, before understanding that, what is the internal intuition behind this min points, what is the internal intuition behind this radius, we need to understand these 3 points available in our Dbscan algorithm. Now, noise or outliers, I think with the name itself, you will be able to get the understanding that those points which are not belonging to any of the cluster, right? They're outliers, they're noisy points. Let's try to understand the core point. What is the meaning of that? Now, let's say you are saying that the minimum point is 4. So it indicates any circle which you are forming up, and in that circle, let's say you're saying that I do have 4 points minimum, at least, means it is following the criteria of having minimum points as 4, then that point is called as a core point. Again, I am repeating. For example, let's try to understand. Maybe you can consider this as a point, this one. Okay? Now you can see, if we'll try to create a circle out of this point, this is the circle that we will be able to have. Can you see my screen? Now, if you will try to check how many number of points belong to this specific circle, you can clearly see 1, 2, 3, 4, 5. In total, in that circle itself, we have 5 points. So, minimum criteria it is following up. And that is what we called as a core point. Okay? Now, next comes yellow, which indicates a border point here. What is the meaning of border point? Again, try to understand. Still a part of a cluster because it's within the epsilon of a core point, because so whatever points are in this radius of a circle, all those points will be considered as a part of a cluster. But if you will see, but does not meet the min underscore points criteria. Means any circle which you can see is a part of that radius, that epsilon, but does not follow this criteria of minimum points. So we cannot say that as a noisy point because they are somehow following this epsilon criteria, but they're not following this min points criteria. Means in that particular circle, maybe you just have a single point, or maybe you just have only 3 points available with you, but the minimum points criteria is 4. So at that point of time, those points are called as border points. So 2 things we have discussed so far. What is core point, which is following both of the constraints, epsilon as well as min points criteria. Those points will call as a core point. What is border point? In which it is following under the category of that epsilon, that radius. So it's a part of a cluster, means border points are a part of a cluster, but they're not following that min points criteria, means their minimum points value is lesser than in that particular circle or in that particular cluster. That's why they're border points. Third important thing, very, very important in our Dbscan algorithm, is the blue point, which is the noisy point. Now you can see when we are following up this circle, there is no as such point which lies in this specific circle, in this specific blue circle, right? So it means that these are somehow the extreme values. If you remember, in a lot of discussions, I have talked about the outliers. What is the meaning of outlier? There are some extreme values, right, which does not follow in the specific data points that we have, the patterns that we have. Those are the outliers that we have, right? So with respect to any data where you're in a need to find or detect the outliers, I think Dbscan works very perfect in that scenario. So that is where Dbscan clustering algorithm came into picture. So these points are called as noisy points, which are extreme values where there is no as such data points available, right? That's what we call as a noisy points. Now, what usually happens is, with the help of this EPS and min points, automatically what happened is our clusters will be formed, and we will be able to either get that core points, or we will be able to get that border points, or we will be able to get that noisy points. Automatically, you will be able to see, after some iterations, you will be able to get that clusters available in a given algorithm. Okay, so for example, if you will just go to the documentation of Dbscan, you will be able to see it's again fall under the category of a sklearn.cluster. From there, you can call this Dbscan clustering algorithm. It's a density based spatial clustering of applications with noise. Now you must have one question, that Priya, why it is called density based? What is the internal meaning of that? Let's try to understand that as well. So here you can see EPS is a maximum distance between 2 samples. You can consider it as a center radius value in a way, right? So the most important Dbscan parameter to choose appropriately for your dataset and distance function. So as I told you, EPS and min underscore samples are the 2 parameters which are very, very important for this algorithm. Again, default value is by default 0.5. Means if you will not define anything in the Dbscan algorithm call, it will automatically take that default value as 0.5. Again, you can see min underscore samples default value is 5. Now, this is important point to understand. Number of samples in a neighborhood for a point to be considered as a core point. Now, you can see if this value is set to higher value, for example, let's say you are saying that my min underscore sample value is, let's say, 15 or 20 or 30 or 40, in that case what will happen is Dbscan will find denser clusters, because you only are saying, you are saying that I want those clusters where at least these many minimum points will be there. So if you will set that value to be very very high, in that case, in a way, you want to say that I want denser clusters, right? Whereas if, let's say, you will apply this min underscore samples value to be very very low, again there is an issue. You will be able to get a sparse cluster, means you are having a cluster but there is very few data points available in that cluster. So by saying that, again I am saying it's a hyper parameter which we need to fine tune as per our data points that we have, so that we will not able to get more denser clusters also, and we will not able to get a more sparser cluster also. There should be a balance between these two, right? Again, all these things apart from this you can understand, you can just check it out. You can see p value is default none, power of Minkowski metric to be used to calculate the distance between 2 points. If none, then p equals to 2, means what they want to say is by default it is a Euclidean distance. If you want to change, because how will they be able to evaluate that value of EPS, the distance metric, right? That is, or anyhow is a value, distance value, right, with the help of which we will be able to form a cluster. So that is again internally is using Euclidean distance by default. If you want, you can just change to other distance metrics as well, right? So these are the parameters that we have in a Dbscan, with the help of which we will be able to form a clustering, right? Now let's try to understand that how can we implement this stuff, right? So what we can do is, we can do one simple thing. We need to import this particular Dbscan first of all cluster. So what I can do here is, maybe I need to import this Dbscan first. So the way we have imported this k-means, right? Similarly, I will try to import that Dbscan as well. So I think in the very first go itself, we have tried to import that. And again, it is also available in cluster only. So let me try to do one thing here. Maybe what I can do is, I can try to paste this and just import the Dbscan. Now, after this, what we can do is, we can try to, call the model Dbscan equals to Dbscan. And now by default, we know the parameter of EPS will be 0.5 and min underscore samples will be equals to 5. Maybe if you want, you can change it. Maybe I just say EPS for now is equals to 0.2 and min underscore samples, because these two are the important parameters that we have in a Dbscan algorithm, which will basically help me to decide the core points, the border points, and the noisy points. Let's say I'm taking min underscore sample size as, let's say, 3, or maybe let's say 4 for now. Okay. Now what we can do is, we need to fit our model, right? So this is the initialization which is done. Now we can say y underscore predicted is already there for k-means underscore, let's say, Dbscan, which is equals to, we will call the model Dbscan dot fit underscore predict, and we will predict on df underscore k dataset that we have. And whatever predictions we will be able to get, let me try to store those predictions as a part of clusters underscore Dbscan, so that we will be able to understand the difference between the predictions that we will be able to get. So what I'll do is, I'll try to store my data inside this df underscore k value, and then maybe let's try to see how will it looks like. So let's see. So now here you can see I will be able to get the clusters value as per the Dbscan as well. Now what we can do is, maybe we can try to understand the Silhouette score and we'll be able to see the performance accordingly. Maybe instead of mentioning that km.labels underscore, now I will mention dbscan.labels underscore. Metric again I am choosing as Euclidean, and again here I'll refer score underscore Dbscan, score underscore Dbscan. And let's try to understand the score here. So you can see this is a sharp increase in the score, which is from 77% to 82%, which is again a good job. So this is how basically Dbscan clustering algorithm works. Even if you want, you can compare clustering algorithms, comparison, visualization. I think there is in sklearn, I have seen that very various number of times. uh, Let me try to fetch it up if I can, sklearn. So which I just want to show you. Yes, this is the picture which I want to display to you everyone. I also refer you all to, just go to this web page. Chrome, just search whatever search I have done and you will be able to get this very nice picture. Now this is again a very great picture which gives you an idea, because till so far we have discussed about Dbscan, we have discussed about hierarchical, we have discussed about how k-means clustering algorithm works. And it's not like we just have only three algorithms. We do have multiple algorithms. For example, here you can see all the algorithms that we have for unsupervised machine learning technique. It's just that whatever be the algorithms which are very, very widely used in the interviews and in the companies, that's what I'm discussing in this course. For example, we have discussed about k-means, we have discussed about Dbscan, we have discussed about agglomerative clustering, which is nothing but hierarchical clustering only. If you want, please at your end also explore other clustering algorithms as well as your task. So here you can see, if let's say our data is very, very weird, in that case, k-means is not performing well in a circular manner. You can see the classes it tries to signify, it's not apt. Whereas you will see the performance of Dbscan is quite apt within a very few seconds. Dbscan is there, which is taking further more seconds. Optics is taking more seconds and is doing a great job. But out of this, Dbscan is the one which is performing in a very, very great manner. That's why I told you that at various times I have seen practically when I was doing the projects, wherever other clustering algorithms fails, Dbscan performs pretty well, right? So that's the major reason I told you that line. Again, if you can see with respect to the clusters which we usually do in our data sets, the row number 3, if you can try to understand here, maybe let me open my Epic pen so that I can show you what I want to signify here. So I think now you will be able to understand in a more better way. So what I'm saying is just focus on this row number 3. This row number 3. You will be able to understand, not this one, maybe this one, this one. See, this is the kind of a data which we usually perform, right? So here you can see my k-means clustering algorithm is also performing pretty well. I think this is k-means only, yes. K-means performing pretty well. Again, here you can see Dbscan is also there. Dbscan is also there, which is performing in a apt way. This is a Dbscan. Yes, this is a Dbscan. So maybe let me try to zoom a bit screen. Then it sounds great. So let me remove this completely and let's focus now here with respect to this point. Maybe let me do one more thing. Let me just remove it again and let's try to understand now. So here you can see with respect to k-means working well. With respect to Dbscan, again working bit well. But in this case, when we have this kind of a data points, I think k-means is doing a better job as comparable to agglomerative, as comparable to Dbscan as well. But when we're talking about this kind of a data, which is a complex data, in that case, Dbscan is performing pretty well as comparable to k-means. So it really depends on what kind of data you are dealing with. You can just check it out, the complete visualization also. So this is a different varieties of data that we have. And you will be able to clearly observe that depending upon the kind of data, different algorithms are there and they are doing a different kind of a job. Maybe for few kind of data sets, k-means is performing better. For others, maybe Dbscan is performing better. But definitely at any point of time, you will be in a situation where you will be like, your data, your k-means algorithm or your agglomerative algorithm is not performing well. Always have this thing in your head, let me try a Dbscan, might be it will work well. Okay, perfect. So I think now is a time that we can simply wrap up this particular Dbscan clustering algorithm session as well. Again, I am saying that at any point of time, also if you will observe in the course part as well, I have always referred the documentation. I am not referring any book, I'm not referring any proper website also. So because whenever I am also learning these stuffs, any new stuffs coming up, because it's a domain where on a daily basis something new is coming up, I always refer these documentations. And I will also suggest you all that at any point of time, whenever you are watching these videos, Please do refer the documentations. Maybe you can open those documentations on another screen. And at any point of time, whatever things, whatever concepts I'm explaining, please do refer that from the documentation as well. This will really help you to enhance your knowledge. Okay. So I hope that now the picture of Dbscan is pretty much clear to everyone. So now I hope that you will be able to get a clear understanding of how Dbscan algorithm works with its implementation also. So in the upcoming part of the video, you will see that now we are discussing a end-to-end project of customer segmentation, where implementation wise, I am applying k-means clustering algorithm. But by saying that, definitely at your end, when you will do the implementation, please try to apply the hierarchical as well as Dbscan clustering algorithm. And your task is to let me know that out of these three clustering algorithms, which one is doing a better job with respect to the loudest score, right? So with this, let's end today's video. I'll see you all in the upcoming videos now. Bye bye. See ya.